Okay. In the next one, we'll be computing for the term of the loan. It means the time. Now, how long will it take an investment earning 18%? What happened? Wait. That's our nominal rate, compounded monthly. So what's our M?
12, ma'am.
12. To double the value. So it means that your principal will be twice as much. So your future value, your F, is twice the principal. Now let's start. What is the value of your I? Can you share with me? What's your I?
0.18. Ay, ay.
0.
Dili pa day, ma'am. Wala pa day, ma'am.
Okay.
Joke lang.
0.015.
Very good. That's J over M. So we have 0.18 divided by 12. The answer is 0.015.
Fine.
Now, we could not compute the N because the N is M times T, right? And how long? The T is missing. So let's go back to our main formula. That's F equals P times 1 plus I to the power of MT this time, because our N is not available. So we write MT. Now, here's how you're going to solve. Remember, your future value will double. So we place here 2. Your principal is 1. It means the original. It's doubled. 1 plus your I is 0.15. MT. Your M is given 12, but your T is missing. Now, let me show you how to solve for this. The first one, divide both, because we only want to have T, right? Divide both by the principal. So divide both by 1. So you have 2 over 1. It's just okay here because the denominator is 1. But when the number gets bigger, do not divide it immediately. Okay? Just like the nominal interest, we need to go to the end before we use our calculators. Next, since we want to get rid of the exponent, you want to do the nth root, but your exponent has a variable, so we will do the application for logarithm. What you will do, have a logarithm of the left side equals the logarithm of the other side. I'm sure all of you have been into senior high school. So we have let us review the law of logarithm. In the law of logarithm, it states that once there is an exponent and you want to expand it, the exponent will go before the logarithmic sign. So in your right-hand side, 12t will go first. Log, you can have it 1.15 now, equals log of 2 over 1. Next, you divide both sides by the coefficients of the logarithmic sign. So we divide both sides by 12t. Sorry, we don't want to have t, right? We divide both sides by this number, the m, and the logarithmic. So 12 log 1.015. 12 log 1.015. We cancel 12. We cancel log of 1.015. So we're left with t. That's an okay. So Because we're left with t, let's use now our calculators to solve this one. The answer will be, what's the time? The answer will be 3.88. Time should be in years, so that's 3.88 years. Questions? There's no questions? So let's have a guided solving in number 2, okay? Let's have the second problem. When is 47,600? What is this one?
Maturity value.
Very good, maturity value. Due if it's present value, remember the present value is also called face value, or it's also called what? What's the other term?
Principal.
The principal. Very good. You need to be very careful of that because there will be so many terms. Is invested at 9%, the nominal interest rate, sorry, compounded bi-monthly. What's our M? Bi-monthly. What's our M?
6.
6. Very good.
6, ma'am.
So what's our I now? Can you share with me what's your answer for I, the periodic interest rate?
0.015.
Very good. That's J over M. So our J is 0.09 divided by 6. That's 0.015. Okay. We cannot solve for N because we don't have the T yet. Let's write now our main formula. So the MT. Our future value is 47,600 times P, 38,400 times 1 plus 0.15. Actually, if you want to make it shorter, you could add this ahead. M is 6 times T. Okay. Tell me what to do next. What should we do next?
Apply the law of logarithm, ma'am.
Not yet.
Ah,
Let's check first.
divide.
Okay,
Divide, ma'am.
divide both
38,000.
sides by
38,400.
the 38,400.
200.
That's why you
Okay.
did not divide this right away, or else you'll get so many decimals. Next, what to do next?
Not extract na, ma'am. I applied it on
Extract.
logarithm.
Okay, logarithm. Log on one side, log on the other side. What happens next? What happens next?
The exponent, ma'am.
What will happen to the exponent?
I-transfer sa tapad, tapad sa log.
Okay, transfer before the logarithmic sign.
Okay.
In your future classes, you say we expand the logarithmic expression. So once we expand, it means the 60, the exponent will go first. I'll just have 1.015, okay? Next, what will we do next?
Divide by M out the
By
6
6.
times 1.0.
1.015.
Oops, don't forget the log. 6
Log.
log 1.015.
15.
Yes, that's it. So very good. You have learned now how to solve a complicated formula using one formula. Now, okay, use your calculators. Let us see. What's the answer for the time? What's the answer for that time?
40 years, ma'am.
Very good. 2.40 years. Pero ma'am, in the board examination, there's no 0.40 years. So what you could do, you can multiply this by 12 months.
12 months.
Yes, because sometimes in the board, you know what, I keep on referring to you in the board exam because that is our direction, okay? In the board examination, sometimes the option will be in months. So we say 2 years and how many months? So you multiply the decimal point, the 0.40 times 12 months. So that's going to be 4.8, right? 4.8 months. Am I correct? I think so. Okay, so this might be a possible option to that one. So we are done with the term of the loan and my time is 2.254. May I ask if you will have a 3 o'clock sharp class?
No, ma'am.
So it's okay for me to continue for 10 minutes?
Yes.
Okay,
It's
so we can
okay.
finish it. Let's go to the next problem. Okay, now, there are two types of interest rate. I think this afternoon you have learned of your J, sorry. You have learned about the J and the M. Not the M, the J and the I. Like the J is the nominal interest rate and the I is your periodic interest rate. But let me add one more. We have the effective interest rate. Now, what is the nominal interest rate? The nominal interest rate is usually used in compound interest. It's the annual compound interest in which your calculation is based. So for example, we say 7% compound interest. That is your nominal interest rate. While the effective interest rate is the equivalent of your nominal interest rate if it will be converted to simple interest. Why am I sharing you this one? Because for example, there is Bank A, and Bank A is telling you that, okay, you invest with us and we'll give it to you at 10% interest rate compounded quarterly. Means 4 times in a year. Well, here's Bank B telling you to invest at them for 11%, but this time in simple interest. By the way, practically speaking, banks have compound interest, but their interest is compounded annually. Usually, the simple interest is used in lending institutions or in some cooperatives. So sometimes, upon looking at the two, if you want to do for investment, you want to go for 11% simple interest rate because it sounds bigger. But when you compute the 10% interest rate at 4, there might be a slight difference with this one. That is why this nominal interest rate can be converted to an effective interest rate so that we can compare if Bank A will offer it in simple interest, how much will be the rate? So how do we solve for that? Again and again, I'm telling you, I don't want to give the derivation. So I will teach you how to derive these formulas. Here's how you'll do it. Remember that in the future value, we want to see that the future value of the two are the same. The left-hand side is for simple interest, while the right-hand side is for compound interest. In simple interest, our future value is equal to principal times 1 plus rate times time. In compound interest, our future value is equal to P times 1 plus, let's use the J over M at the I to the power of MT. Okay, next. We divide both sides by P since it's common. So no more P. Next, 1 plus RT equals 1 plus J over M to the MT. Let's assume that RT is equal to 1. It means that we're just looking for a 1-year period, 1-year conversion of the two. So what will happen? The right-hand side will become 1 plus R because T is 1, right? The right-hand side will become 1 plus J over M to the power of M. Okay. We will, once you want to get rid of the M, then we will do the square root sign. But remember, our goal here is to find for the R. What is the R? The R is the effective interest rate. We are looking for our R. So we will transfer 1 to the other side. Therefore, if you're looking for R, we can solve it as 1 plus J over M to the power of M minus 1. This is the formula for the effective interest rate. Once you will convert the nominal interest to effective interest. What if you will convert the effective interest to nominal interest? Actually, these two are called equivalent. It means they are the same. Equivalent interest rates. What if you convert equivalent effective interest to nominal interest? Then, okay, let's go back here. The 1 plus R. So, we'll have 1 plus R equals 1 plus J over M to the power of M. Our ending should be J. Okay? So, okay, apply what you have learned a while ago. Extract. You want to get rid of M? Extract the mth root. So, cancel. Then what's left? There's still 1. So, the mth root of 1 plus R, you transfer 1 to the other side, minus 1. There's M here. You multiply all by M. This is now the formula for J. Okay, you can take a screenshot of that or a photo of that one. Are you done? Then we can go to the next. Let's have a sample problem. It's also in your notes in page 91. Let me clear that. Let's go to the sample problem. Find the effective rate of interest equivalent to 17% compounded by monthly. 17% compounded by monthly is our nominal interest. And we will compute the effective rate of interest, or effective interest rate, R. So let's solve. That's R equals 1 plus J over M to the power of M minus 1. During the board examination, you're not allowed to start deriving formulas. You're only allowed once the time starts. So you can do the derivation as long as you see a problem like this. That's 1 plus the j is 17. What's our m?
6.
6. Okay, to the power of 6 minus 1. Now, using your calculators, what's the answer? What's the effective rate?
$18.25.
Very good. That's 18.25%. So you see, this one is in simple interest. So example, Bank A offers you at 17%. Bank B offers you at 18% simple interest. Still, the 17% is better. Because if you convert the 17% compounded by monthly, it's equivalent to 18.25%. That's why I told you, you need to convert it first before you check with 2 corporations. Let's go to problem number 2. You're almost done. Up to problem number there. Now, the next question is, what rate converted by monthly is equivalent to the effective rate of 11%? This is the R, the effective rate. And we are looking for its equivalent rate in nominal interest, in J. We're looking for J. Let us have the formula for J. M times, your M last time is in the end, right? You can place it in first. 1 plus R minus 1. Okay. What is our M?
6.
6. So 6th root of 1 plus, what's our R?
0.11.
Very good. Minus 1. Okay, using your calculators, what's the answer? What's your J?
10.53%.
Very good, 10.53%. I understand that some of you might be using that two-line. Alam mo, two-line calculator, tagduha lang yung siya tanan. So, my advice to you, you invest in a good calculator. But before you invest in a good calculator, see to it that it's in the list of calculators allowed for the board examination. Before I bought a calculator because it's really good, just to realize it's not allowed in the board examination. So, wag yapon siya. It doesn't make any sense at all.
Actually, dapat nang pwede, ma'am.
There is a list given by PRC. So you Google this time on the list of allowed calculators for PRC board examination for teachers, because some casual calculators are very advanced and they are not allowed. So this is a very good advice that I could give you. Your calculator this time, the one that you will practice, must be the one that you will be using in your board examination. And invest in a 4-line calculator. How do you know it's a 4-line calculator? Once you will press the fraction, you see the ABC. it will give you index in the screen. But in a two-line calculator, it will only give you like this. Divide, like that. So invest on a four-line calculator. Now, the next one. Which is better? To invest money at 9% compounded quarterly or at 8% compounded monthly? Actually, this one will ask you what is the effective interest rate on the first one? And what's the effective interest rate on the second one? So you have two to answer. Let's start. R is equal to 1 plus j over m to the power of m minus 1. So 1 plus, what's our j in the first one? What's our j?
0.9.
0.09. Okay, good. What's our m?
4.
4. So the power of 4 minus 1. So what's the value of your r? What's the value of your r?
9.31%.
Very good, 9.31%. Let's have option B. R equals 1. What's the J in our option B?
0.08.
0.08. What's our M?
12.
12, because it's compounded monthly. Raise the power of 12 minus 1. Okay, compute for your R in the second one. What's the value of your R in option B?
8.30%.
8.30%. Now the question, which is better? Remember, what is our perspective? We'll invest money. So you want a bigger rate? So we'll go for the first one, 9% compounded quarterly. Let's go to the last type. The last type is called compounded continuously. What's the practical application of this? In the banks, it's in compounding interest, but it's compounded annually. In MVC Co-op, it's compounded quarterly. So every quarter, we see our money growing every 3 months. But if you'll go for stock trading, it's continuous compounding. What do you mean by that? In compounding interest, our smallest M can be 365. That is daily. But in continuous compounding, it means every moment. They say the moment is the smallest unit of time, but it's not acceptable in for mathematics majors, right? It's the second. Now, every moment your money is increasing. That is why we say it's continuous compounding, or we say compounding continuously. Now, what will be the formula for compounding continuously? The formula will be future value is equal to principal times e to the power of jt. The e here is the e that you will see in your calculators. Hope you can see the e. It's the neighbor of log. Diba? There's log. There's also, di na siya in ha, ln. That's the natural logarithm. And then you also see e. So they are neighbors each other in the calculator. So for example, to put a fund of 46,000 in 5 years and 3 months, convert this to years, that will be 5, 3 over 12. So we will have our time of 5.25. How much must be invested at 17% compounded continuously? This is your maturity value, your F. And you're asking how much must you invest? You're asking for the principal. Let's have F equals PE to the JT. That will be 46,000 times P times E to the J power of J 0.17 times T 5.25. Okay, you tell me what should you do next? What should you do next? Our ending should be P.
Divide.
Divide both sides by
Both side. E. Then
E to the power of
of 0.17
0.17 times 5.25.
for 25.
25.
Again, do not multiply it, or if you want to multiply it, copy all the decimal points. What will be the value of your principal? What's the answer? What's your principal now?
842.
There's a point?
18,843.
Yes, that's it. 18,843. That's your principal. So your 18,843 will be invested at 17%, compounded continuously for 5 years and 3 months, and it will result to 46,000. But mind you, practically speaking, there's no bank that will offer you 17%. There's no bank which will offer you continuous compounding. So you only find this in cryptocurrency and also in stock trading. So that ends all for today. I think the rest of the problems, you can simply handle it in our material. Thank you so much for joining me today.